I can't bet on Purdue games anyway, but those people that are like in California, what are they betting? I mean, they're betting on the winner.
Theoretically,
It's gonna be close.
last I looked, I think they had Penn State on
So Penn State by 4?
That's what it was.
Yeah. I'm just
That was
wondering.
early in the week.
Yeah. You know, there's more and more betting, sports betting. What is it that? See on TV.
FanDuel,
Underdog. Yeah, it just, people are being smart about it, not losing their paycheck. You know what I mean?
That's why it's there.
Yeah. So the business is only in business to make money, so you know they're making more money than losing. Penn State by 4. Okay, that'll be interesting.
I know. I was like, was it really? Kind of like, I don't know, I want to be more cyberpunk. But it also leads to go on
Okay, I think I'm gonna start out slow, but, you know, I usually try to wait till the 35 because people coming over. How many got out of the class at 4:20 and are you here? Okay, look at, so there's probably others that had to get out at 4:20 and I will talk about something that you don't have to put in your notes. It's my shirt. If you notice, I got a possum shirt and people are interesting. I mean, I wouldn't have bought this myself, okay? I buy dogs. I don't know if I have any cat shirts, but it reminds me I should. I got a couple ordered for cattle. I got some cattle shirts coming. Anyway, why do I have a possum shirt on? And I was telling some people this earlier, but I'm gonna tell everybody, that way I can waste up some time in case somebody's coming. I had a friend that had a housewarming party, I guess you'd call it, and everybody was supposed to bring something to pass, you know. And so I'm a jokester, so I had a can that looked very authentic and it said possum stew. And you can get these gag gifts, you know, there's companies on the internet that'll sell you things that say something and it's not really that. So I think it was full of sand or, you know, something inert. And so I brought this can of possum stew. I said, we're gonna open this and everybody has to try it. And you should have seen the looks that I got. You know, so I put it on the counter and I said, I'll open it later once, you know, we, you know, get to the desserts or something. And of course it was a gag gift, I had to tell them that. But it was very authentic looking. So then last week they gave me this shirt, the person that had the housewarming. So it's a possum shirt. Probably the only possum shirt I'll ever have, but anyway. So that took me close to 35. So I want to recap. What I want to do, well, I always want to answer questions first. So then I'm going to see if the audience has any questions on physiology or whatever. This week has been spectacular about asking questions, and some of you are asking questions about my educational background, how did I get this experience? I sound like a surgeon, can be considered an experimental surgeon. You know, make sure you know that I'm not a DVM, I can't go neuter somebody's dog, although I have, but it's off the record, you know, years ago. I was just, maybe I'll do that. I was lucky enough, all the way through my undergraduate days, that I worked with mentors that were always doing experimental surgery for a physiological reason. See, this one more person came in and didn't miss anything. So I've done all kinds of stuff, but it's all experimental. Like, you'll never know a veterinarian that would take the sheep, exteriorize them, electrocauterize any follicles that were a certain size and above, and then put them back in the animal and come back 2 days later. You know, nobody does that. Counting the number of CL in gilts, I did 300 a fall with a laparoscopic surgery. That's where you have the punch in, and you know, somebody was asking me yesterday, what do you fill up the abdominal cavity with gas, with oxygen before you punch in the bigger ones? And the answer is yes, but you use carbon dioxide. You have this little needle. The gilts were in a special carrier that put them in a 45-degree angle with the head down. And then all the intestines kind of want to rush, I shouldn't say rush, go towards the diaphragm. And then there's a certain place you would put a small needle. And the needle was so neat. It was hooked up with carbon dioxide. But the needle was such that, you know, how a regular needle, you can't hide the tip. You know, you go in. But this needle, you went in with a sharp point, and then there was a sheath that went over the sharpness so it wouldn't puncture any intestines if the pig moved. So it's kind of neat. You did that, and then you filled up so much carbon dioxide. And one thing I said is, like, when I was learning this, I go, gee, why not oxygen? And the answer is carbon dioxide stimulates breathing. Oxygen doesn't stimulate breathing. If you get too much oxygen, your breathing will stop because the blood will be fine, right? So they do carbon dioxide, and it's less hazardous, but when that gets absorbed into the membranes of the pig, it's going to stimulate respiration. And the thing is, all these pigs were on inhalation anesthesia, and we didn't use an endotracheal tube. We just did a Hylex bottle that's the bottom cut off. We shoved that on the snout and then duct tape around, and we had, you know, complete air thing. Anyway, so I've had a lot of questions. Somebody in this class asked about heart, heart valve defects in the ventricles. Yeah, raise your hand. She lives someplace where there is an inordinate number of people diagnosed with this condition. And this will be a great word. What she described to me, because remember what I said about some people think everybody that dies should have an autopsy. And I'm kind of in that camp, so you can kind of monitor what's going on with the population. Because some people will die of a certain kind of cancer, but then they also have another kind of cancer. You know what I mean? And you miss that. Or somebody dies of a heart attack, but they also had a big tumor that you'll miss. And if you die of a car accident, it'll be blunt force trauma is the cause of death, but actually they had a brain tumor as well. That might have caused a car accident, right? So we were talking about this cluster of these especially in the left ventricle, the valves are being diagnosed as, I'll say faulty, just to keep it straight. And it sounds like it's a cluster. And a cluster is something where there's a preponderance of this condition in an area, but nobody really knows about it until it's studied, it's looked for. And then I said, gee, that sounds like a teratogen. So I want to start with that, and then I'll see if there's other questions. So I'm going to go and tell you what a teratogen is. And when you diagnose these things, of course, you have to train yourself into, and so I'm training you guys how to fish. I don't give you fish, I'm training you how to fish. And when you brainstorm, there are no bad ideas. Nothing. You just let it all out, especially if you're with other people. You know, the sky's the limit. My last class that left here, they're supposed to make a business plan, and I told them, cost is no object. If you want to make a 3-story vet clinic with a dog park on top, do it. because reality strikes you soon enough later. Dream a little bit. So a teratogen, and it's spelled just like that. Terat, oops, sorry. Terat, oops, sorry. I gotta watch what I'm doing here. I've got too many chords. So see where it says teratogens, teratogenic? That's what I want to go to. And before I punch it, and we'll see what it comes up with. But basically, and now listen to this wording. Teratogens are factors that mess with the development of an embryo and or fetus. Now see how elusive that is? I didn't say chemical, I said factor. That's a better broad term than chemical. There are thousands of these, and especially you women out there, if you ever work someplace where there's chemicals or some company, be very aware of what chemicals there are in your lab, in your, you work with. Things can go through skin, things can go through certain gloves, things can be inhaled, whatever, but they affect the development of the fetus, and the embryo, I should say, right? Anytime, I guess you could say it affects anything from the zygote all the way through birth. Yes?
Are teratomas caused by teratogens?
No, that's something different. So teratogens, a factor that causes maldevelopment of, let's say, from the zygote all the way to birth. But now that's very elusive because it can be hidden. It can be something that's very slight. That's how biology works. It can be something very slight that may not ever be discovered, or maybe discovered when the person has a surgery and they go, what's it? You know what I mean? Or it can be very detrimental and the fetus dies. All the way from slight, undetectable, and anyway, so teratogens. Let's see what it says. Agent or factor that causes malformation of the embryo, and I would add fetus. The reason embryo is focused on is that's when all the organs are developing. Embryo is more subject to damage than a fetus. The fetus is basically everything's there, but it's going to grow. But we're talking about teratogen, and so she was telling me this case. There's not enough money to do studies for local towns, but to me it rings like a teratogen where there's something going on and it's affecting the valve development of the embryo. That's why I said teratogen. And it can be hard to trace down. And I was telling her about a vet I know that quit the vet school and went to North Carolina and is working in a hospital doing this exact thing, looking at how many diseases come in. And it's a big metropolitan area, so you get a good handle on, things that are happening out. And he was hired to study the different illnesses, diseases that come in and see if there's something going on in the environment, which is very smart to do. So teratogens, a factor that causes malformation of the embryo or fetus, but the embryo is more likely to be affected. So, what I'm trying to say is keep asking the questions. It doesn't have to be directly on domestic animals, but I'll tell you sometimes I just say, I don't know about it. I don't know anything about that. I'm not going to make up an answer. I'm going to tell you what I know, and otherwise I'll say, talk to somebody else. Anybody have any questions from this week? Lab? Anything? After I leave here, I'm going to work on a guideline to write the lab report.
So you said the lab's due in 2 weeks, so the next week or the week after?
It's 2 weeks from yesterday. So the lab, does anybody know what date that is? I guess that's
September
14th at midnight. Oh, okay, that's a Thursday, right? That's a Wednesday, yeah. Okay, that's right. Yesterday was Wednesday, yeah. Okay, so Wednesday at midnight, so you have 2 weeks. And I'll make some little format, okay? I'll put something on the website where it says, we use this, but you're gonna name it anatomical terms, you're gonna have planes, you're gonna have directional terms, or, and then maybe say you should have a miscellaneous section where some of the things we talked about. And I've got a list here, a couple things that I want to make sure everybody knows about. Because here's what happened I noticed in the lab the other day. So I do something in the first lab. There's 4 labs in a row. Can you imagine standing up and doing these? You can't do the same thing 4 labs in a row. Because people ask a question and I'm off answering that. But there's a couple things I want to make sure everybody knows about. So anyway, so in 2 weeks, okay? And the first one's going to be straightforward. Remember, it's not going to, that one, everybody came to the lab, they're going to make the same type of lab report. But remember, when we start doing the wet labs, you'll maybe work with a liver today, 1 lab, and then, maybe three livers, but not anything else. And somebody else across the table is working on the intestinal tract. See, but that way we can make good use of every tissue that comes. We'll have somebody, I've got a hacksaw and a vise, we'll do a medial, mid-sagittal cut through the cat brain. Okay, things that no one else does because they're too busy cutting things and then you leave. No, we're gonna, like I said yesterday in the fixative, I can put any part in a bag and they'll be there. It doesn't have to be frozen, doesn't have to be thrown away. When you dissect fresh tissue, you have that time and then that's it. Because if you put it in a refrigerator, it's like a piece of meat, it'll be rotten. And if you freeze things, somebody might say, why don't I go out to the farm and get pigs that die or take them and put them in the freezer? Do you know when they thaw, they start breaking down? And you don't get a good dissection, to be honest. Because when you thaw them, here's what happens. The outside thaws first, so that starts what's called autolysis. But the inner core is still frozen. So then you end up like with a pig that's mushy. And you have to do it all because once you thaw it, you're not going to go freeze it again. So like I told you that yesterday, the cat's $150 and I have over 30 of those. So it's like, it's worth it because everything is preserved. We don't have to hurry. I don't have to worry about autolysis. That's A-U-T-O-L-Y-S-I-S. Whenever you see lysis, that's a suffix that means the breaking down of. And it's amazing, dead animals, dead people undergo autolysis. A lot of bacteria start working, cells die, and a lot of gas formation. And that just wrecks tissue. So I don't want to get it. Anyway, teratogens. So does that answer on the lab thing? Yeah, probably. Okay. Anybody else have questions? Because I want to answer questions more than I want to talk about what I want to talk about. You know what I mean? Because that's how you customize your knowledge. Yes.
So the lab report is in fact individual report.
Yeah, it's an individual. Yeah. And I'll make sure that everybody does a lab report. Yeah, it's not a group thing. You had a partner, and you can rely on them, but don't write the lab report together and then double it. You know what I mean? Because Turnitin will say, oh, I'm not sure if you guys know how Turnitin works. Even if everybody submitted their thing at the same time, it won't scan it all. It scans from one class one at a time. And then it remembers that. And then it scans the next one. So sometimes when you submit it, you don't get a similarity score right away because yours is in a wait list. So be aware of that. So you work with people, and we're going to switch partners all the time. I like that idea. And you can talk all you want, but then when you sit down and write your lab report, don't do it with the other person. You might email them and say, what was that part that had that, that dent in it or whatever? What's that body cave name? And that's the fossa and whatever. So, okay, other questions? Good. Okay, so let me do lateral for a minute. And we talked about this in some labs, but I know there's at least one lab that I didn't give you all the words you can make that end in lateral. So some of you know this, and maybe you don't know all the things I'm going to do, but I know there's at least one lab that I didn't say this at all. Okay, so here's my favorite online dictionary, onelook.com. I think I have no money with it. I don't make any money off these guys, but I think they have like 100 dictionaries it searches when you do something. But I'm gonna show you how to search for words that end in something but start with whatever. Now, if you have a paper dictionary, you can find all the words that start with AB, right? They're there, AB. But how do you find all the words that end in lateral but start with whatever? And I'm gonna show you. And you can do this forever. And sometimes I do it to make up tests or quizzes in some classes. Like I want all the words that end in emia. E-M-I-A means deficiency of. E-M-I-A is a suffix that means a deficiency. We all know one word that ends in emia. What if you're low on hemoglobin? Anemia. A-N is a prefix that means without. So anemia means without blood, but that's not, any deficiency. Okay, anyway. So let me do onelookdeck.com, and it's a dictionary. What does it say? 19 million words in 1,000 dictionaries are indexed, okay? When I was in college, I had one dictionary, maybe a medical dictionary, and I couldn't look up any words that ended in lateral, unless I looked at every page, right? I'm going to show you in 2 seconds how to look up every word that ends in lateral but starts with whatever. Then I'm going to pick out ones that you should learn, and we might run into some that I didn't mention at all yesterday, but I'm going to tell you. So here's the kicker. If you want to find everything that ends in lateral, but you don't care how many letters in front of that, you do an asterisk, and then you do asterisk lateral. That tells the program, the dictionaries, find everything that ends in lateral, but starts with something else, and it probably finds the word lateral too. But I don't care how many letters in front. But let's say you're doing a crossword, or making a crossword like I do, and I want to end in lateral and maybe have 4 letters in front of it. So if you know how many letters, you go question mark, question mark, question mark, question mark, lateral. So maybe I should demonstrate that. So if you know that you only want 4 letters in front of lateral, like when I make I have a crossword puzzle I'm making. I've got a crossword program at home that makes crosswords like you find in the New York Times. Do I have time to work with it? No. There's people that do that, right? I can make simple ones pretty fast, but anyway, so let me do this. Let me do 3. Question mark, question mark, question mark, lateral. So I found 9, okay? You cannot do that with a paper dictionary. Now I'm going to go and show you how to find all the words that end in lateral, and I don't care how many letters in front. Here we go. Now, it found a lot, but then there's a good way to kind of trim it down, because some are 2 words, like buck lateral. I have no idea what that means, but I always click on usually common. Okay, so bilateral, now we're taking notes. Bilateral is one of the things I said yesterday and in one of the labs, or at least a couple maybe. So bilateral, and then what's neat about it is all these are hyperlinked, so you could go look at the definition, and it means both sides. So I did a bilateral ovarectomy on all the sheep we had on that one study. Bilateral ovarectomy. Then I want to do 5, contra. C-O-N-T-R-A lateral. That means the other side. So I did a left adrenalectomy and a contralateral nephrectomy. Then IPSI, number 11. IPSI. That means same side. So I did a left adrenalectomy and an ipsilateral nephrectomy. Then C lateral is also given. And then, somebody in one of the labs did trilateral. I guess you could write that down. Of course, that's going to mean 3 sides. But the 4th main one I want to talk about is unilateral. So I know if I take a young pig and do a unilateral nephrectomy, And if I came back in a year, the remaining kidney would be larger than any of his cohorts. The remaining kidney compensates and grows bigger than it would normally do, than if there were two. I mean, that's an easy experiment to do, right? You have 20 pigs that you don't monkey with, you have 20 pigs that you did a unilateral nephrectomy and then come back in a year and weigh the kidneys. The ones that have one kidney is always going to weigh more than any of the other kidneys that are both there. It's a compensating factor which works especially in young people. So like if you know somebody in your grade school that had a unilateral nephrectomy for some reason, their remaining kidney is bigger and can make more urine than yours because it's, okay, I'll have to say it, it's called compensatory hypertrophy. And it's an interesting physiological so compensatory. And actually, I'm not, my high school English teacher would say, Rod, see, you should have studied spelling better when you were in high school. Compensatory. And then hypertrophy. There it is. So somebody else, oh yeah. So this is what's neat. I'm showing you how to study these things. I'm explaining them. Compensatory hypertrophy is where if you remove one organ of a pair, the remaining organ says, I've got to grow bigger than I normally would and try to compensate for the loss of the one. It works, I'll say, in most paired structures. Here's where it doesn't work, lungs. Because there's nowhere to go with a bigger lung. But it works with kidneys, it works with ovaries, it works with testes. Compensatory hypertrophy. Let's see what somebody put down. Increase in size of an organ or tissue when called upon to do additional work or to perform the work of a destroyed or a paired organ, right? I like my definition bigger. Move one part and the other part grows. And I'm not sure how that works. I'm not sure what the signal is to make a bigger kidney. It's probably then you don't have two kidneys working, so the amount of waste products that the remaining kidney is working on is a little overwhelming versus the two kidneys. That's probably it. So for that one person, when you take out one kidney, all of a sudden, the other kidney is faced with more waste products. You see that? Because you took the kidney out. But now the other one, if the kidney was diseased that you take out, maybe the other ones had already started to grow. What's interesting, so anyway, I don't want to go too far into that, but it's called compensatory hypertrophy. Or, here's another thing. If you starve an animal and then feed it, it's going to grow faster, it's going to eat that feed and be more efficient on that feed than it normally would have if you didn't starve it. Just weird things, right? Okay, so I did the lateral, I did this. There's another word that I know none of the labs got. Anybody have a question? Here we go.
So in cases of supernumerary, would this apply as well? The thing that's
Okay, so she's talking about supernumerary, and you're probably referring to that kidney. Remember the one picture, right? Is that, yeah. So there were like 3 kidneys.
Yeah.
It just depends on how functional the extra kidney is. And remember biology, always remember this. There could be a slight effect, or there can be no effect, right? There can be a little effect, and then all the way to crazy effects. So it just depends. All those things are a case-by-case basis. If the supernumerary kidney was functioning just like every other kidney, you probably could remove one of the 3 now, and maybe the other 2 wouldn't do anything as far as growth. See, it's like most people have 2, and if they were normal size, then they probably wouldn't grow. But let's say the 3 kidneys are all smaller than normal, so you remove one, I bet the other 2 would grow. It's not going to be stuck with just growing one organ. You know what I mean? The factor that causes kidney growth is going to be affecting the other two kidneys if you remove one of the three, right? Remove one of the three. So anyway, it's very interesting. And kidneys are another thing interesting. When people get kidney, recipients get kidneys, they tend not to remove the original two. Unless they're cancerous and they're gonna metastasize and spread cancer all over. If they're just so dysfunctional that you need another kidney, they leave them in, and I'll tell you the strategy. First of all, it doesn't matter where you put a kidney. It needs an arterial supply and a venous supply. It can be any place, it can be on your arm. You could put a kidney on your arm, and it would make urine. And you'd have to have, you know, hook the ureter to a bag or whatever, right? So here's what they do with kidney recipients. They put them low in the pelvis and then hook it to the bladder. Your kidneys are lumbar, high lumbar. So they put it low pelvis and hook it up and not disturb the other ones. But they were dysfunctional, they needed some help. They were, I won't say dysfunctional, they were lower in their capacity than they should have been. But here's why you try not to remove the original two. What if the one that's transplanted gets rejected? Tissue rejection. And it has to be removed. You can buy some time with your original two. Remember, you were making urine with those. But if you took the two out and the transplanted one gets rejected, now you have no kidneys. So again, that's a case-by-case basis, but leave the original two in, even if they're operating at 20% function, add the two, that's 40%. And maybe you needed another kidney to get up to normal. But if that gets rejected, and you know that's tissue typing, right? There's a whole art in histocompatibility. Yes?
If you have like if you have supernumerary and you have like an abnormal amount of like kidneys, and you know that something's wrong with them and you need to take one out, how do you measure the effectiveness of those kidneys?
So to decide,
Yeah.
well, you would measure the arterial supply and analyze what's going in, and you would take the venous supply and see the difference. So and it's like there's a waste product called urea. If 10 units of urea go into the kidney and 10 come out, the kidney's not doing anything. That's the one you would remove, let's say. But if 10 go in and 5 come out, well, then it's doing something. So you compare the arterial supply with the venous supply. And that's kind of neat with a kidney because the difference would be only due to the kidney, right? Because it's isolated. The blood going into the kidney, you could have a parameter and then do the same parameter with the venous outflow, and the change would be directly because of that kidney, okay? Good question. It's all physiology, and it works in animals, dogs, cats, horses, us. Yes?
What if somebody has like kidney failure? Like how would that
Well, kidney failure, you know, and dogs have that all the time, and unfortunately, there's a big genetic component. I'll tell you a personal story. I had some friends that love mastiffs, but they tend not to do their homework. If you buy a some purebreds are too inbred, right? In fact, maybe you can say most purebred dogs are inbred to some degree. Anyway, they bought this beautiful mastiff. From the get-go, it had chronic renal failure, but it was this much failure when it was young. And then as it grew, the failure became more evident and progressed to the point they had to euthanize the dog at 3 years of age. And there's a strong genetic component, because this brings up that cluster thing. I'm going to write a formula on the board, and this thing is so powerful that it tells you a lot how to investigate things. And P equals G plus E. And you know, if you ask somebody what would you do over again, if I was in your shoes, I would study more genetics and biochemistry than I did. P is phenotype. That's what you see, that's what you can measure. Height of a person, the weight of an organ, blood pH, hematocrit level. It's what you see or can measure. That is based on two factors. It's an interplay between the genetics that you have, your chromosomes, and the environment that you're in now. But here's the interesting thing. Even the environment you had as a fetus or an embryo. And that reminds me, okay, somebody remind me to look up the T word I'm thinking about, okay? When I get done here, I'm gonna look up this T word that does this. Anyway, so the phenotype, chronic renal failure now. The dog had it, but it was undetectable. Maybe in a research lab setting, you could have done some analysis and said, for dogs, this is this is too low of efficiency for something. But it was very healthy. Remember, they didn't do their homework. If you ever buy a purebred, you should call people that have bought that breed of dog from that person and do some homework. I did that when I did the Newfies, and there was one beautiful, I met her. There was a lab tech at a vet clinic that she raised Newfies, and she goes, Rod, the one people you're talking to, I've never heard of them, and I've been in Newfies 20 years. Okay, I gotta cross them off the list. I don't wanna buy a dog from anybody she knew Newfies. She had like 8. Can you imagine having 8 Newfies? Anyway, phenotype, what you see, what kidney function there is a play between genetics and your environment. But make sure you know the environment can start from the time you're a zygote. It's called intrauterine environment. I mean, it's powerful. I can tell you something, I don't want to. Anyway, yeah, so the environment isn't only now, we're in this environment, right? We can measure air quality. We can measure, I got a device that measures carbon dioxide. You'll never see one. Sure, everybody's got a device, hopefully at home. You guys have home monitors for carbon monoxide. Carbon monoxide? I've got one right on my briefcase. I never stay any place without one. And it's a professional one. It measures 1, 2, 3 parts per million. I don't think it's reading anything now. Anyway, this is powerful, and you can explain a lot of things. So chronic renal failure is genetic, but because the animal maybe was well cared for, and it's young, nothing's showing up, but it kept getting worse, and then I think the dog at like 2 years of age was, not looking healthy. They took it to a vet clinic. They diagnosed chronic renal failure. They gave it so many months to live. And then by 3 years of age, they had to euthanize it. Beautiful Mastiff. They didn't do their homework because there's a large genetic component for a lot of diseases. So it's amazing, right? You gotta, do your homework. Whenever you buy any kind of animal, do your homework. Talk to people that have bought from that breeder 10 years ago. Like the Newfies I had, 180 and 160 pounds. You think they might have had some hip dysplasia or something? They never had anything wrong. The female did get pyometra, we could talk about that, but that's not really so genetic, but it could be. But anyway, the big male, 180 pounds, feet and legs, he lived 10.5 years, that's pretty good for a big dog. Bigger dog, the shorter the lifespan. But from the get-go, I always trained him how to do steps and ramps. Never jump down from the pickup bed, never jump up. He was perfect. So he had great genetics, because I talked to people that have bought their Newfies from these breeders. I was all set to go, but I've known too many cases somebody does an impulse buy, and then they euthanize the dog, either because cancer develops. There's a genetic component to a lot of things, depends on the environment too. It's amazing. Okay, other questions? Okay, so compensatory hypertrophy. I want to do intercostal. That's what I know, one thing I don't think I did yesterday. So now I'm kind of wrapping up what we did in lab, which we can do in lecture, because lab reports are supposed to incorporate everything we do, right? Tests incorporate everything we do. Why would we isolate? Well, we didn't do that in lab, so you don't have to write about it. No. because it's all up here for you. So intercostal. So one thing I like about it is, like this morning I was thinking, what didn't I do for all labs yesterday? And this is a word that I don't think mentioned at all, but I might have, after, 4 labs, it blurs. So intercostal is an interesting term. It means between the ribs. And notice what popped up? I mean, so I kind of like how it pops up because it's other things to talk about. But surely between every rib there's muscle. So there's intercostal muscles. And if you know, and by the way, it's skeletal muscle. Skeletal muscle needs a nerve to tell it to move. So you got intercostal nerves, intercostal spaces, whatever. So that's a term. And then I had a question, I think it was Tuesday after class, and I'm going to explain that a little bit better about the packed cell volume and hematocrit. Some people are having a little trouble visualizing that, especially if you haven't worked someplace where they're doing that. So let's do hematocrit. And I'm going to show you an image, and so here's, and that's what I haven't done in the past. I haven't shown you an image. And this image is pretty good. Okay, so here's what you got to realize. Blood is made up of a fluid portion, and then the solid portions are what's called formed elements. They're things that you can see with the microscope. You can't see glucose, you can't see testosterone, you can't see vitamin A. It's all in there, but they're dissolved. You can analyze for them, right? You can analyze, how much glucose is in blood, but you can't see it. But the things you can see are called formed elements, and that's all the blood cells. So there's a lot of red blood cells, then white blood cells, and then platelets, okay? Red blood cells are brainless. Brainless means they don't have a nucleus. And platelets are brainless. They like to clog injuries in blood vessels, but they do it brainlessly. Red blood cells are brainless. They circulate by the heart, but they can't divide, they can't move. But white blood cells have a brain, and many of them have a very smart brain. They're so smart, they can smell trouble. And it's something when we do immunology, it's so neat that if you have if I get punctured by a barbed wire, some of the white blood cells leave my bloodstream and go to the injury. That's pretty darn smart. Usually things can't leave blood vessels. But if you have a brain, you can leave blood vessels. Anyway, this hematocrit. So what you do is you collect blood sample, right? I can collect the biggest bull I ever worked with, 2,400 pounds. I lift his tail. I can do a vacutainer, 10 cc's, no problem. I can take a blood sample from him in a half a minute and go on to the next one. And in the tube, you have 2 choices. You either have plain tube. Now that's not like the plain cat we were talking about yesterday. A plain tube means there's nothing in the tube. When the blood's drawn in, there is nothing in the tube. The other choice is you have something in the tube, some chemical, and heparin is a common one. And we talked about that. Common anticoagulant. If you have the plain tube, the blood is going to start clotting right away. We always let it clot in the refrigerator, and we use so many hours, and then we spin in the centrifuge. What happens in the centrifuge when you spin it, all the formed elements tend to go down. And the red blood cells go down first, and then the platelets and white blood cells sit on top of the red blood cells, and then what you're left with is with fluid. And if you let the blood clot, the fluid is called serum. So clotting equals serum. So plain tube equals clotting equals serum. But if you have heparin and you spin it in the centrifuge, you get the same separation, but on top you call it plasma. So then a hematocrit is often done with these small little hematocrit tubes, and it's got an anticoagulant coating, probably heparin coating the walls. So then it allows a separation. And then you measure, so like we said by convention, what's the hematocrit value for every animal we work with by convention? 45%. So what that means is, if you look at the total, and now I'm on the screen, if you look at the total height, that's 100%. And then if you look at the height of the red blood cells, that's 45%. 45% of the total. And see that total, and this is a great example, if you draw 10 cc's from a sick animal, a healthy animal, whatever, the height of the columns are going to be all the same. Because 10 cc's, you don't lose any fluid or anything in the centrifuge unless you mess up, and that's bad. If you didn't balance the rotor, if you've never done that and don't know how to balance a rotor, don't do it. When I was at Nebraska, somebody took an experimental, a big centrifuge, and they didn't balance it. I don't know if they were spinning rumen fluid or, it was in the nutrition lab. It tore the whole centrifuge apart because the apparatus in there fell off the shaft and it went around. It was crazy. Anyway, a sick animal. So here's what we got. We've got a normal animal. I've got an animal with anemia. And actually, anemia means, is actually blood. I stated that wrong earlier. Emia means blood. It's a suffix meaning blood. So this means without blood or low blood. The column is the same. And then we have an animal with polycythemia. You should know what that means. Poly always means many. Emia means blood. Correct that in your notes, because earlier I think I said deficiency, and that's another word. And then cyt, C-Y-T, that refers to cyto. Cyto means cells. So polycythemia means too many cells in the blood. So you should know that, lo and behold, you can have too thick of blood and it doesn't flow through all the capillaries right. And every animal has a number, right? And I said 45% for all animals, but that's a lie for some animals, right? It might be 50, it might be 40, it varies by genetics. I bet you can find some draft horses that have 50 and another breed of draft horse might have 53. You know what I mean? So you spin it, you get red blood cells down here, and you measure that height, and that's hematocrit. So they're saying down here, and this is interesting, this is a diagram from a human source. And what they're saying at the bottom is, for females, their normal hematocrit varies between 37 and 47%. But if you're a male, you vary between 42 and 52. So sex makes a difference. And the kicker is, look at my value of 45, it's in the range there. It's easier when we have a test or, it's easier to say, okay, 45, but make sure I'm lying, that you know I'm lying about all the animals. I'm just doing one convention.
I just have a question. What does the T in the formula means?
So what's that?
The T, the formula of the P equals G
Yep.
plus T. What does the T mean?
What does the E mean?
T, the T.
The G?
That letter T, like the last one?
Well,
G.
the last one is E, sorry.
Oh,
This is a plus sign, maybe that's what you're, yeah.
Oh,
This-
okay.
This is plus.
Oh,
Sorry. Okay,
Yeah.
good question. See, that's the value of asking questions. He didn't leave the room with misinformation. Yeah, it's plus. So anyway, the buffy coat contains the other formed elements. Remember how I said red blood cells go down to the bottom, and they stack up how many there are, and then there's a little cap on the test tube, a cap on the red blood cells. But you know what? Sometimes you can't see it. There's so few of them, you can't see them with the naked eye. If you probably put them under the microscope, that area, you could probably see some. But sometimes you can't see it, but you should know that the white blood cells and the platelets sit there, so that means there's no cells up here. But if the blood sample is handled wrong, then there'll be fragments of cells up here. and that will be a red tint. It won't be yellow and every species is different, and by the way, your diet affects what the color of the plasma is. Yes?
So, when I used to work at a vet clinic over the summer, and I performed some of these, like putting the test tubes in the
Mhm.
centrifuge.
Yeah.
And, a couple of times, like, there was a pink liquid that formed on top.
Yeah.
And, I don't know.
Yeah, pink yeah, it can be very light red as pink. And you know what happened? It's called hemolysis. I'll write that down. H-E-M-O, maybe I'll just spell it. H-E-M-O-L-Y-S-I-S. Hemolysis. That's what happened to those tubes where there's a red on top. Hemolysis. H-E-M-O-L-Y-S-I-S. Lysis, you learned earlier, breakup of. Hemo means blood. So it's a breakup of red blood cells. So something happened to that sample that caused red blood cells to break up, and I'll tell you the most common reason: the presence of water. Water in a test tube will cause hemolysis of the red blood cells. And when we talk about, it's all about osmotic pressure. The red blood cells, well, okay, so the second one though could be trauma. If you do blood samples with a syringe and needle, and if you apply too much pressure, or too much vacuum, I guess, when you're pulling it, you're gonna break red blood cells. That's probably what happened maybe. But there's, yeah, if it's pink, so if it's slight number, it's kind of pinkish, but it gets darker, darker, darker. And maybe we'll show some pictures in a minute. Yeah?
You know also what the separation is called? Because there's sometimes food on top, or let's say there's plasma on top, and then there's like a white barrier, and then there's the elements that collect at the bottom.
So are you saying a white barrier?
Yeah, there's, I think there was a white barrier in the middle after.
Oh, are you saying that was in the test tube before you even put the blood in there?
No, after.
Oh, after. Okay, well, so I don't know, okay, so here's that buffy coat, but if the animal is fighting a disease, it'd have a lot more white blood cells, and maybe you'd see it more. That's probably what it is. The reason I asked if it was in the tube before, because there's some special tubes that you can buy that have these little beads in them. And when you spin the blood, the beads go on top of the cells, and it's easier to pipette out the serum or plasma. How many have seen those little beads? Yeah, but that was in the tube before you put the blood in there.
I think so, yeah.
If you see something afterwards, it's probably because there were so many white blood cells there, that buffy layer is higher than normal. Okay. So anyway, you have this thing you spin. Notice everything else is up on top. Water, yes, but it's not pure water, right? It's, plasma. Proteins, nutrients, hormones, you name it, minerals, vitamins. Okay. Now anemia means there's less red blood cells per volume. So you take 10 cc's. Remember, we took 10 cc's from all these people. These are people. Well, lo and behold, if you have anemia, you still have red blood cells, you still have white blood cells, but there's less, so your hematocrit goes down. So a dog or a person or a horse with anemia has less than normal hematocrit. And it's also called Paxil volume, right? They still had, you drew 10 cc's of blood, but a lot of it was not red blood cells like a normal, okay? Now what's kind of interesting is the third case, polycythemia means the animal is making too many red blood cells, or has too many red blood cells in its blood. There's many reasons for that. One reason is the body is fails to take old red blood cells out of circulation. Just because they're there doesn't mean they're functional. Your red blood cell, okay, how long do red blood cells live in a dog? Think of this. How long are they functional? Remember, they don't have a brain. Anybody know? Can you say a figure that's kind of an average? Here's our convention. 100 days. Does that fit every animal? You better say no. Right? That's not the value for every animal. It's Rod's convention. It's easy to remember. It's easy to put in a lab report or a test, but it's a lie for some animal. But it's not a bad figure to realize that it's only 100 days. So think of that, a foal that developed It's in the uterus for 300 days. It's already had red blood cells form and die before it's even born. So anyway, this is polycythemia, but I'm going to tell you another way to get that same result. So you get the idea, you took 10 cc's of blood, you got a lot of red blood cells, so you have an elevated hematocrit, elevated packed cell volume. Here's one more way to do that. If you want to ever do that, if you ever see that in a lab or whatever, the other way to do that is if the animal is dehydrated. So make sure you understand that. Dehydration leads to increased packed cell volume, and make sure you understand why. Dehydrated animals have elevated packed cell volume. Okay, so I saw a question, yeah.
So, like, if you were seeing, so I worked at a vet clinic, and if we saw a foal with like low IgG levels, we would give it plasma. Like, what's in that plasma to help that?
IgG, okay, and plasma. Yeah, okay, here's the deal. And you could write this, if you're writing this down, it'd be a perfect thing to write on this list. Oh, see, these questions are like incredibly valuable. IgG is a type of antibody. And so if a foal has needs antibodies, you only have to give it plasma, not the whole blood. Because antibodies are found in the plasma only. Yeah, and that's an interesting case. Sometimes somebody remind me of how a healthy foal can nurse its mare, its mother, and die 2 days later. Anybody know what I'm talking about? It's an interesting story. A healthy foal getting milk, 2 days later dies. No, I'm not going to answer it. I'm going to let you think about it. What's your question?
I was going to guess.
Oh, your guess then.
Lethal white foal syndrome?
A lethal white syndrome? No, but that's an incredible subject. That's here.
Yeah.
In horses, if they have 2 copies of the white gene, they die in utero. That's what you got. And that's not this. But see, look at how many topics we talk. Genetics, that's how important genetics is. If the horse has 2 white genes, it kills the foal. If the foal has 2 white genes, I should say. You know, the mare has nothing to do with it. It dies in utero usually. It's fascinating. Horse genetics, my gosh, all that coat color stuff. Anyway, so dehydration does that, okay? So now I want to show you an image of pink or red plasma or serum, okay? Love these questions. Go ahead.
One last question. So people who are anemic have more plasma in their body than people who are not anemic?
Yeah, because they lack red blood cells. So you could think of that. So you took 10 cc's out, but you could take all the blood out of an animal that was anemic and spin it, and they would have more plasma. Now remember, I'm saying plasma because I did an anticoagulant.
So this might be dumb, but if
No, don't ever say that. It's dumb if you don't ask it.
if you're adding plasma, like giving the full plasma, could that lead to anemia?
No, because the body's going to compensate. You're not going to give that much volume. It's going to compensate because fluid flows in and out of blood. So, you know, if you have a lot of excess fluid, a lot of it will be leaving the blood stream. Unfortunately, some people don't realize that. You might have never heard of this case, but a woman died from drinking too much water. And unfortunately, it was a contest put on by a radio station. And somehow they had all these bottles of water, and whoever drank the most got a used car or a new car, I can't remember what it was. She was so desperate that she won, and then died the next day. Because you mess things up. Everything's got to be in a balance. Your blood pH has to be in a balance. It's got to be 7.4 or close to it. And this poor woman, and the radio station, I think, got sued from the woman's estate, and they should have been. Or, too bad somebody wouldn't have told her, do you know you can die from this? But she was so desperate, for a car, crazy, but yeah, it's amazing. Yes.
So what's the connection between like people who like typically are anemic get a lot of fainting spells? So how does that have to do with
Well,
red blood cells?
the red blood cells carry oxygen. If you don't get enough oxygen, you faint. And that's the key. They just aren't getting enough.
Well, like basically most clinics or all of the clinics like use serum for kind of like for the veins and everything like that, other medications.
Are you asking why a lot of clinics use serum rather than plasma?
Yes.
Is that the question? Okay, here's the kicker. You have to know what is going to be done with that sample to then decide whether you use a plain tube or a heparinized tube. There's other anticoagulants too. So if you're doing a test, let's say Eli Lilly does a test on some drug that they are developing, and they feed it, they usually give it to young men on these drug tests. Then they take blood samples, but they'll know, did the chemist develop the test to use serum, or did the test call for plasma? It depends on your endpoint. So like when we were doing like testosterone in boars or estrogen in sheep or whatever, we always use serum because our assays were based on serum. But if you have a test that's based on plasma, then you need plasma, And, so that's why it's a case-by-case basis. It's not like I like serum better than plasma. No, that's not it. It's like, what's going to be done with the sample? Why is it being taken? And sometimes you might need to have a test that has serum, and some might have plasma. Well, then you need 2 tubes of blood. See, it either goes, from the get-go, you can only do plasma in 1 tube or serum in 1 tube. You can't do like, oh, I'm going to get this stuff before it clots and gets plasma. No, you can't. It's like either or. And that's why these tubes the blood collection tubes come in different sizes. You've seen them like 1 cc. I use 10 cc's on large animals. Anyway, I'm going to show you hemolysis. You wrote that down, but that means a breakdown of red blood cells. So you can think to spell hemolysis, but that's not what you say. You say hemolysis, but if you want to spell it, you go hemolysis, right? So hemo, and look at all these, okay, hemorrhoids and all these things. Okay, hemolysis. There it is right there. So I'm going to click on hemolysis, and first refers to the destruction of red blood cells. And so hemolysis refers to the destruction of red blood cells from many causes. It might be a disease, it might be water in the tube that or whatever. I love that definition because they're not stretching it out. They just say destruction of red blood cells. Typically, okay, they say 120. Is that pretty close? Yeah, in some semesters I might say 120. 100 came to mind, right? And so body naturally destroys them. Yep. An old red blood cell, think of this, looks like it came from another person. It looks foreign. If you ever get a bad blood transfusion, the immune system attacks them. And so in our own bodies, when a red blood cell gets old, it looks different. I guess it's kind of like looking at college students versus all the old people in the lower arena of Mackey. Don't you look different? So anyway, that's quite a stretch. Anyway, so then look at this picture. And see, that's kind of neat. They have a thing about hemolysis. I'm sorry. I do donate to Wikipedia. So I gave him some money a while ago. But look at this. So make sure in Wikipedia you can enlarge the figures, the images. And if you wanted to do this for your lab report, I would do a screen capture and put it in my folder where I'm talking about blood. So what this is saying is no hemolysis, I'm not going to even read the legend because I know that's no hemolysis. And then more. And see, look at this. If that's faint enough, it kind of looks pink, doesn't it? If you imagine a tube in here that's had a little bit, you'd say that looks pink. And the kicker is, like sometimes we took blood samples from cattle every 15 minutes for 2 days. Think of that, how much blood, if we want to monitor some hormones. If somehow we had hemolysis in some of the samples, it was bad because then that might wreck your assay. It may or may not, okay? But hemolysis basically is always bad, but a little bit you might be okay with, you know what I mean? But if all the red blood cells get ruptured, then that might mess up the assay that you're doing. If you ever worked in a chemical lab, especially a research lab, not a clinical lab like a vet clinic is a clinical lab, but if you're ever in a research, like I was doing testosterone levels in boars, measured nanograms per mil, everything is so persnickety that many things can mess it up. Like one time, one of the lab techs was on birth control. She messed up our progesterone assays. She had progesterone in her breath. And the assay was so delicate that when we were doing progesterone, we banned her from the lab. Get out of here. I mean, I didn't ask if she was on birth control. She goes, because we were wondering about our assay. Because when you do assays, you always have positive controls, negative controls, a standard curve. Everything is very persnickety. And she was messing up our progesterone assay. So, you know, she probably went and did paperwork. Anyway, that's hemolysis. Okay, let's see. Any other questions? I got one more term I want to talk about. Sinus, S-I-N-U-S. Now you're going to say, oh, sinus, like you have trouble with your sinus? Well, and it's something somebody asked me yesterday. The term sinus is an anatomical term, but it just means a chamber filled with X. It doesn't mean your nasal sinuses. You say nasal sinuses, but then you're talking about a chamber filled with air. But I'm going to talk about a sinus that's filled with blood. So, and somebody brought this up and like, you know, sometimes you got to expand what you think you know, right? Sinus, well, it can be filled with blood. And now I'm going to write this down and we'll see what Google does with it. I'm going to talk about the carotid venous sinus in sheep. So I go carotid, and you know that refers to the big arteries in your neck. And that's where people bleed to death. Little kids get bit by a dog. You can, you know, if you cut, did I talk about that in this class? Well, it's the other, oh, one of my other classes, we were talking about dog attacks. 2 or more dogs are a pack. Anyway, if you cut your carotid on either side, there's 2, that's the main blood vessel that brings up blood from the heart. And for little kids, if they get bit by a dog, they can bleed out very fast. There's also the jugular vein. That can help, not help. That can cause you to bleed out. Not help, yeah, sorry. And then there's one other area that's very tender and known to have people bleed out. In your inner thigh, your femoral artery and vein. People have injured those. There's a story like some young college kid was climbing a fence. And have you ever seen those fences with the wrought iron arrows? You know, he slipped, cut his femoral artery, and the shaft ran into his leg. He was caught there. They found him the next morning dead, blood all over the brick wall. But he couldn't get out of that, the shaft that went in his leg and it cut his femoral. That happens too many times. Anyway, carotid venous sinus. So, what does this mean literally? And this is kind of confusing because the carotid is an artery and then venous means vein. And sinus means an opening of, but it's the base of the brain of a camel and sheep, and it helps cool the brain. The carotid venous sinus, what a name. Let's click it and I'll show you a picture. So it's a this is a network of veins that sit in a cavity. Now here's how to think of this. Think of this room as filled with warm blood. So this is a sinus filled with warm blood. But through that wall, we have pipes running from that wall out this wall. And it's got venous blood in the pipes. So this room is full of arterial blood. The pipes are carrying venous blood. There's no mixing at all, right? The venous blood is in pipes. This room is filled with arterial blood. But there's going to be heat exchange. Every surface of that pipe is exposed to the blood, the arterial blood. And like I teach in spring in environmental physiology, heat always flows down its concentration gradient. It always flows from warm to cooler. Arterial blood is always warmer than venous blood. So the arterial blood that's floating around in here is going to give some heat to the pipe. The heat is going to go into the venous blood, and then it's going to go out that wall. So you're going to cool this part. This is at the base of the brain of the sheep and the camel. Now, lo and behold, there's a big hole over there where the carotid blood goes to the brain. It's going to cool off and go to the brain. And it's going to cool off because the venous blood was exposed through the wall. And that's called the carotid, venous sinus, and photoplees. And then what I'm going to do is sheep. All those pictures were, every animal has this, but some are more efficient. And the reason I say camel and what did I say was the other animal? Sheep, because they have a better example. Okay, so here it is. This is a great figure right here. And you know, in these figures, red is always arterial blood, and blue is venous. So here's the deal. The blood that's cool in the pipe is coming from the nose. And when you breathe across the membranes, you're going to lose, heat is going to be picked up by the air and taken away from the tissue. So the bottom line is, this venous blood goes through here. Anyway, so there's a big chamber. So the bottom line is, I know we're going to go, but there's heat exchange. Carotid, venous, sinus. Okay? See you guys next week. Go Boilermakers. We'll see, huh? Of course, if you're at the game, you can study physiology at halftime.
That might be pushing it.
You said that you were wanting to talk about ANC like during.
Yeah. Remind me of two things. Yeah, I forgot.
Okay.
It wasn't teratogen. It was a teratogen that starts with T. So, yeah. That's okay.
I don't get a sneak peek into the next lecture.
Okay, I'll start spelling it, and you figure it out. I hope you can get your right. That's a T word, that's a teratogen. Okay, now you want to look dictionary? Check in CHARO.
I'm reading my mind here.
Just to be sure that so the carotid venous sinus is basically like a heat exchange, like
Yeah, it's a heat exchange because the arterial blood is always warmer than the venous blood.
Okay.
So then it's going to cool the arterial blood before it gets to the brain. Yeah, so it's a heat exchange mechanism. It's like a radiator in your house or your front of your car. The air is coming through the radiator.
What does that do?
Well, the air that's coming in is cooler than the water in your radiator, so the heat is going to transfer from the antifreeze through the wall. And you know how the radiator hose has a lot of surface area? Because it's directly related to how much surface area you have. And so heat is going to flow from your engine into the antifreeze, out your radiator, air is coming through, so some heat by conduction is going to go through